Good afternoon, ladies and gentlemen. Audience for this web series lecture by Dr. Satish Shenoy and students of the Department of Meteorology and Oceanography and the students elsewhere in India and abroad. I welcome you all to this lecture by Dr. Satish Shenoy. It would be my privilege to introduce Dr. Shenoy to the audience. Dr. Shenoy had an early schooling from Tiruvarur in Kerala. He graduated in 1978 with physics major, and then he did his MSc in physical oceanography from the School of Marine Sciences, Cochin University of Science and Technology, and he obtained a PhD also from CUSAT in 1984, and he has more than 30 years of experience in the field of physical oceanography. He played a lead role in the ARMEX program of the DST, Government of India, which changed our traditional view from a passive role for the ocean in monsoonal process to an active role in the monsoonal air-sea coupling. He showed that the regional optimization of the algorithm coefficient could improve the estimation of the SST over the Indian Ocean using satellite-based infrared sensors by 15%. After the very famous tsunami struck the Indian coast in 2004, December 26, he coordinated the research that described quantitatively the tsunami of the Indian coast and enabled an improved estimate of the extent of the tsunami source region. He was a senior member of the group that carried out hydrographic observations during 1987 to 94 to map the seasonal cycle of circulation of the Indian coast. Considering his contributions to the understanding of the physical oceanography of the waters around India in 2007, he was elected a Fellow of the Indian Academy of Sciences. He has authored more than 75 research papers in journals of international repute. His professional interests include observation oceanography, ocean currents, impacts of oceans and monsoons, and satellite oceanography. Currently, he is also a recognized PhD guide of the Goa University. He had many national roles to play, and prominent of them are in April 2009, he was appointed as the Director of INCOIS, and he was a provider of the Operational Ocean Information and Advisory Services. And then he is the Secretary of Regional Alliance for Global Observing System in the Indian Ocean region, as well as with the Region Data Center and the Clearinghouse. And he has wide membership of academic and professional bodies. He is a member of the Governing Council of the Ocean Society of India, and then he is a Vice President of the Ocean Society of India during 2006 and 8. He had an H.N. Siddiqui Memorial Lecture, Indian Geophysical Union. He is a Fellow of the National Academy of Sciences and a Fellow of the Indian Academy of Sciences. With these few words, I welcome Dr. Shenoy to deliver his lecture for the sake of Andhra University students. Thank you, Dr. Shenoy, and I welcome you. My voice ratle chudu. Yeah.
Yeah, sorry. Now can you hear me?
Yeah,
okay,
yeah.
Thank you very much, Professor Ramakrishna. Can I start the lecture?
Yeah.
Okay. Let me just upload the PPT. Just give me a second. And can you see my PPT now?
Yes, Dr. Shenoy.
Okay. I'll put it in slide view. It's fine now, right?
Yes.
Okay. Thank you very much for inviting me to deliver this lecture in the Andhra University webinar series. The topic I am going to talk is because I'm keeping the interest of students also in mind, because Andhra University means mostly it should be more beneficial for the students. So the topic I have chosen is need for an ocean observing system to monitor the changing climate and its consequences. During the course of my talk, I'll be posing some of the questions which some of the students might like to pick up for their research and conduct research in answering those questions. That's why I posed some of the questions during the course of my talk. As we all know that our climate is warming, the entire Earth system is warming, and the data shows that it is warming at a rate of about 1 degree Fahrenheit per decade. And the temperatures have crossed more than half a degree if you compare from 1940s onwards. So the entire Earth system is warming, and this warming is a continuing process, though slow, but it's a continuing process. But there are a lot of criticisms about whether the Earth is really warming, because the critics will argue that they will mostly they will use this graph and argue that hey, see, even in the past also the carbon dioxide also has increased, and it's a cyclic process, and the temperature also has increased. This graph shows that for the past 800,000 years or 8 lakh years, how the carbon dioxide and the temperature cycle varied. So it kept on cycling, going down as well as going up. So what is the problem then? Can't this warming also be part of one of this kind of a cycle? Anyway, we are on the upscale of the cycle as per this graph right now. But the issue is, you can see that in the past, the carbon dioxide in the atmosphere never exceeded 300 ppm. I had drawn that line to mark that limit. It maximum it increased was up to only 300 ppm. But if you look at the present climate or the present concentration of carbon dioxide in our atmosphere over the past couple of centuries, it is already 409.8 ppm. So this is the problem. So that is why it is a reality that the carbon dioxide is increasing in our atmosphere, and the temperatures are going up. And this has broken the natural cycle of the Earth system, where in the past also the carbon dioxide increased and the temperature increased. So that cycle has exceeded, or that limit has exceeded, and that is why we had to worry about the climate change and the Earth system changes that is going now. So where this heat is going now, because the carbon dioxide is increasing, means because of the greenhouse effect, the more heat will get trapped in the Earth's atmosphere, and that heat cannot just remain in the atmosphere alone. So the IPCC estimates, it shows that only 1% of that excess heat is remaining in the atmosphere, and 3% goes in warming the soil or our land, and 3% goes in melting the glaciers, and the maximum 93% of the excess heat which is going into the Earth system is going into the oceans. So oceans are taking 93% of this excess heat what we are putting out into the Earth system, and the ocean is keep on storing this heat because the reason is simple, because oceans can hold more heat because its specific heat is higher than any of the others, and it's a slow changing environment, so oceans can keep on accumulating this heat. But our oceans are very important for us, because oceans contains 96% of the living space on Earth, has 80% Earth's living organisms in the oceans. So only 20% are living on the land, and oceans covers about 71% of the Earth. And almost half of the oxygen we breathe is produced by ocean plants called phytoplanktons. And fish provide fish available from the oceans. It provide the necessary protein for the most of the more than 50% of the population of the world, and 90% of the world trade is carried across the ocean. And more importantly, oceans are holding nearly 80% of the mineral wealth of our planet. So all these are available from the oceans, and we cannot afford to destroy the oceans by accumulating the heat. Or at least we should know the accumulation of the heat, what it will do, and how it will affect our oceans. So in a warmer world, increased carbon dioxide in the atmosphere will lead to increased carbon dioxide in the oceans, and that increased carbon dioxide in the oceans will change the physical properties of the ocean, and consequently the entire marine biogeochemical cycle. So these are all cyclic changes, one after other. These changes will keep on happening in the oceans. So the warming of the ocean is a reality, and with 95% confidence level, we can estimate those the changes. And this graph shows how the sea surface temperature has increased from 1850 onwards till recent, and it has increased by about half a degree compared to 1940s. And before that, it was below about half a degree sometime in 1900 to 1920. And the 1940s onwards, we slowly started the industrialization, and slowly we started emitting excess carbon dioxide into the atmosphere. Because of it is not that only the sea surface temperature is getting warmed up. Even the upper ocean water column, at least the data is available now up to about 700 meters, and if we estimate the heat content, even that shows that the the upper ocean water column is getting heated up. Even maybe even below that also it is getting heated up, but we do not have sufficient data to quantify that kind of heating. But certainly up to 700 meters, we know how the heat content is increasing. There was a paper which appeared in Nature Geoscience in 2015. It spoke about a hiatus, or something which has stalled, and they showed that over the global ocean, the heating, the acceleration of heating, or the speed at which the heating is happening, has come down, or it is getting this hiatus period, and it is very slow. Not only that, they also showed that or the Pacific, it is not no more heating. It started cooling. But their third graph, that is what I have plotted here in the middle, which showed that Indian Ocean is warming at an accelerated pace, because it has become more slopy. So Indian Ocean is warming. Pacific is slowly cooling during the period 2002 onwards, and because Pacific is doing that on an average, globally it is also has slowed down. So that is what it reflected in these graphs. And on the left hand side, the various fluxes are shown there. So you can see that the total flux is increasing, But the QNet is the fluxes which are put out by the atmosphere, like latent heat flux, then sensitive heat flux, short wave, long wave, etc., etc. So that if you look at the Indian Ocean, that has either come down or it is not increasing. So it is an interesting question for the Indian Ocean, that Indian Ocean is warming at a much faster rate, but the atmospheric heat input into the Indian Ocean actually has reduced compared to the other previous years. Then another paper appeared in Science into the same year by Veronica et al. That clearly showed that during the previous decade, 1993 to 2002, lower layers of Pacific, about 100 to 300-meter layer of Pacific, was much warmer compared to in 2000, in the later decade, that is 2003 to 2012. And you can see that the Pacific has become cooler and cooler, and the Indian Ocean is becoming, on the left hand side is Indian Ocean, and the Indian Ocean is becoming warmer and warmer. Whereas in the previous decade, in 1993 to 2002, Indian Ocean was little more cooler, but now the Indian Ocean has become is becoming warmer and warmer. So these are intriguing question, that how Pacific is cooling down and Indian Ocean is warming. Of course, this cooling down and warming, these are all very relative terms I am speaking. So don't take it as a Pacific no increase in the these are all anomalies. So don't take this as Pacific is cooling down. That's not correct. So if the warming continues at the present state, by 2100, we can see that the Indian Ocean will warm up to about 0.13 degree per decade. That means right now, whatever is the temperature, another couple of degrees more, it will warm up. And if it is following RCP 8.5, the scenario which everybody is afraid of, then the things will go haywire, and per decade itself it will warm up by more than 3 degrees. That means from 2020 to 2100, that means 80 years, 8 decades, by 25 centimeters. That means we will not be able to step out in the oceans if that is the kind of scenario what is going to happen. So there are different propositions why this warming is happening in the Indian Ocean, and one of them proposed by Rahul and Granashilan. They say that the westerly winds, they have enhanced, or they became stronger by about 1 meter per second, and that those westerly winds, they are pushing the thermocline down, or the mixed layer is deepening, and that is what is manifesting as the warm northern Indian Ocean. Another theory which my colleague Dr. Chatterjee proposed was that there is a meridional circulation which is developing, and he has shown zonally averaged meridional velocity from core to simulations that shows that the cross equatorial cell, that is becoming stronger, and there is warmer subsurface waters in the Southern Ocean, which have been already reported by Allori et al., the Australian authors, that in the Southern Ocean, surface to 800 meter is getting warmed up. So that heat is getting transported into the surface of North Indian Ocean. That is another theory they have suggested. And myself and my student, we looked at whether we will be able to do some heat budget calculations and find out what is causing this heating. So we draw a box around the Indian Ocean, southern side and eastern side, joining Australia and Indonesia, and Malaysia, so that the Malacca Strait, that region also is covered. And anyway, western side it is completely blocked, so the heat can get in or go out in this box from eastern and southern side. And we did a heat budget calculation. So are using different models. We used about 5 models: SODA, ECNWF, GICO, GFDL, and GODAS models. And all the models are successful in showing that trend in SST increase, as you can see here. That is about 0.1 degrees centigrade per decade, as shown by the observations it is showing. But as you see here, the heat budget do not show that any of these are accumulating the heat, or there is a trend in the transport from the Pacific, or the transport across the southern boundary, or even going down, or the because we have calculated upward and downward heat transfer also. None of them are showing. That means the warming is captured by the models, but the data, the models are not able to reproduce the budget correct. This does not mean that this budget is correct, because but they are unable to, maybe because the models are not getting the advective fields or the currents right in their model. That is what it turns out to be. So though we understand the extent and magnitude of the warming trend, we still do not have a clear understanding on the amount of heat entering and exiting the Indian Ocean through the various ocean atmospheric pathways. Neither we know how that accumulated heat is going to influence the air-sea interactions, affecting the weather and climate of the region and globe as a whole, given the monsoonal process itself is a complex phenomenon. One of the reasons is the inability to accurately perform a heat budget analysis due to lack of long-term high-frequency data over regions like the Western Indian Ocean and the Indonesian through-flow region. We do not have sufficient data still to quantify a heat budget, and that is where we are failing at that.
Dr. Shanae, is there any problem?
And now it has increased by more than 100 or 125 millimeters, or it appears that earlier it was increasing at a rate of 1.7 millimeter per year, between 1901 and 2010, and now it increased to 3.2 or 2.8 to 3.6 millimeter per year after 2010 since 2010. So that means the sea level is keep on increasing or changing, and the story in the Indian Ocean is not very different from the tide gauges data, which is plotted in the upper panel, as well as the tide gauge data from other islands in the Indian Ocean. All of them are showing that the sea level is increasing at the rate of about 1.7 to nearly 2 millimeter per year. And even the model simulations, the ORA S4 model simulation also shows that some of the regions, the sea level in the eastern region, the sea level increase is much higher compared to the western side or in the Arabian Sea side, and the sea level is keep on increasing. And if you look at the sea level increase along the Indian coast, you can see that the sea level is increasing at each of the stations at different rates. I have shown Haldia, Diamond Harbour, Paradeep, Visakhapatnam, Chennai, Tuticorin, Kochi, Mangalore, Marmagaon, Mumbai, and Kandla. And each of these locations, the sea level is increasing at different rates, on an average 1.7 millimeter per year, but it varies from 0.7 to in Haldia about 5 millimeter per year. So Haldia, that 5 millimeter per year may not be the entire thing, is because of the sea level rise due to the thermospheric heating or addition of glacier melt into the oceans. It could also be due to the land subsidence which is happening there, but we do not have the data to quantify how much is the land subsidence is happening. So right now we are INCOIS is trying to put a GPS along with this tide gauge so that we can get some accurate estimates on the land subsidence as well. But right now we have 36 tide gauges all along the Indian coast, and this data is freely available from INCOIS, and any researchers would like to avail this data, they can approach INCOIS and get this data. So two questions again remains. Does those rates estimated using the data of previous decades, or I have shown in that table, for example, Chennai data was from 1916 to 2005. Similarly, Mumbai data is 1878 to 2005. Does these rates remain same, or it has changed? We still don't know. So this new data has to be analyzed for that, and the young researchers can utilize this data and find the answer for does those rates estimated remains the same in the last decade or have changed. And the second point is that what are the errors on these estimates? Because these are all estimates using the data, and with the availability of more data and from more sophisticated instruments, because the accuracies have increased now, have they improved in the recent decade, or the errors are still remaining the same as the data which was used using that chart recorder type of tide gauges? These are some of the interesting questions which needs to be answered. So increasing the atmospheric carbon dioxide, additional CO2 dissolves in the ocean, that changes changes temperature and the salinity and solubility and chemical equilibrium of the gases. And because of the physical properties are changing, the circulation in the ocean also will change, and supply of carbon and nutrients from below, ventilation of oxygen depleted waters, downward penetration of nutrients, everything will change, because more warm water will create more stable condition or a stratified condition, and it will slow down the mixing process itself in the ocean. So in the warm ocean, another thing what is happening is, because carbon dioxide is getting dissolved more and more in the ocean, because it absorbs more carbon dioxide from atmosphere, the increased carbon dioxide, and the carbon dioxide in the ocean is increasing. So the pH also is going down. It is becoming more and more acidic. So I have shown some of the data here. The one side, it is carbon dioxide on the left side, and dissolved carbon dioxide at Bermuda, Canary Islands, and Hawaii, and right hand side, Hawaii, Canary Islands, and Bermuda, the pH. You can see that left side is going up and up, and the right side graphs are showing downward trends. From the Indian Ocean, we have only recently started making measurements of carbon dioxide. One sensor on in the Bay of Bengal that started measuring a couple of years back, and another sensor in the Arabian Sea that started just a year ago. So we don't have this kind of records from the Indian Ocean right now, but certainly the story will not be different from this. So the IPCC projections are that if things goes present day, we are somewhere here in the pH graph, as that arrow is showing, that is we are slightly minus, so slightly we are becoming acidic. And if every country maintains that Paris Agreement goals, then we may go to about 0.6 or minus 0.6 or minus 0.06, minus 0.06, slightly acidic. And if we continue business as it is, then we will go to minus 2.2 or so. And if business is as the business is as usual, then we will go to about 0.33 or so. That means the ocean waters will become heavily acidic compared to what is there now. So this graph clearly shows that if we don't change and stop adding more and more carbon dioxide into the Earth system, the danger is much more than what we can take. And if the carbon dioxide increases and pH level goes down, then somebody, Crocker et al. Have shown what is the effect on different processes and different species in the ocean, how they will, how their growth, how the photosynthesis and survival of these species like coral reefs, the mollusk, the other crustaceans, etc., how they will get affected. It's very interesting to read this paper and understand how the various processes like photosynthesis will remain almost same, but metabolism of the organisms in the sea will change. Similarly, their development will get affected, growth will get retarded, etc. So that is the kind of difficulty. And we also know that the waters are becoming deoxygenated, or oxygen in the seawater is getting depleted. So the question is, are we running out of oxygen in the oceans? And unfortunately, one of the largest oxygen minima zone is in our around us in the Arabian Sea and Bay of Bengal. You can see that blue means very little dissolved oxygen in our waters, and if things continue like this, the oxygen depleted waters in the waters around India will collapse our fisheries, as well as it will change the entire biogeochemical cycles. So the IPCC has also given the projections different scenarios. If it continues like this, where we will go in different scenarios. So it looks very scary that we may run out of oxygen from the oceans, or the deoxygenation will soon will happen. But one solace is that all the models which are used for these projections, they don't agree each other. So we don't know whether that projection what is shown is really going to happen, because some of the models even showed a negative opposite sign to the other. So that is one encouraging factor, that the projections may not be may not be right. We don't know exactly, but may not be right. But we cannot take that granted and sit just like that. So the if we but we had to improve the determination of oxygen and its projection. So the way out is we have to take a integrated multi-scale approach, where experimentation with in situ data and continuous data collection from the oceans, and the side by side we had to develop the models, validate against the data, and perfect these models. So for that, the Global Ocean Observation Network has been designed, and I'm glad that 57 countries are participating, or about 30 countries are participating in this Global Ocean Observation Network, or GOOS, and coordinated by Intergovernmental Oceanographic Commission of UNESCO, and generating a lot of data from different kind of platforms. One of the important platform which is generating the data from the ocean is the Argo floats. These are self-profiling floats. Once they are thrown in the water, they will go down like I have shown in this schematic. They can go down, park there, whatever time we determine or program for those floats. And when they come up, they will record the temperature, salinity. And these days, they are also equipped with oxygen as well as nutrients and other parameters. So they will make a profile or data, come up and stay on the surface for a few hours, 6 to 12 hours, and transmit that data via satellite to the data centers. So we have more than 600, nearly 700 floats in the Indian Ocean as well. And India also is part of this international Argo float program. Other data set which is more easily available is the sea surface temperature from satellites. So in situ data and satellite data, this kind of SST, chlorophyll, sea level, etc., are available, and available from satellites. That data also is easily available for long periods of time, some of them since 1980s, and some, for example, altimeter data is available from 1994 onwards, not before that. And the chlorophyll data also is sometime in 90s onwards. Similarly, the XBT lines carried out by different countries, they are available, and India also is part of all these programs, and we generate lot of data. And India is maintaining this moored buoys, about a dozen buoys in the Bay of Bengal and Arabian Sea, collecting the data which is used for weather, the cyclone predictions, as well as the climate forecast. National Institute of Ocean Technology in Chennai is maintaining these buoys, and this data is now available for more than 20 years or 2 decades from most of these buoys. It has even the ocean currents, upper 500-meter currents also are continuously available from this. And in addition to that, India also is part of another mooring program led by NOAA of USA, and China, Japan, Indonesia, and India. These are all countries which are collaborating. Even South Korea also, we are collaborating and maintaining a large number of moored buoys in the Indian Ocean, especially on the equator and southern part, also in the central Arabian Sea and central Bay of Bengal. So, as per the design 46, these buoys are called Rama buoys, or research moored array for African, Asian, Australian monsoon analysis and prediction. 91% of this mooring array is complete now, and that data also is freely available for anybody to take out and analyze that data to find answers for various questions. Need not be only for climate purpose, for even for any other kind of science. These data are available. Similarly, India has established about 14 ADCP moorings all around the Indian EZ, and this makes measurement of upper ocean currents or the upper 400-meter water column currents, and that data also INCOIS and NIO are jointly maintaining these ADCP moorings. That data also is available from INCOIS for anybody to conduct research on the coastal currents. It's a beautiful set of data which is available. Similarly, the XBT lines, the India is constantly monitoring the upper ocean thermal structure between Chennai and Port Blair and Port Blair, Calcutta, as well as Cochin, Lakshadweep Islands, and also Mumbai and Mauritius and Chennai, Singapore line. This also is a continuous data set for more than 30 years now. So 3 decades of data is available for that. But the issue is we still don't have much of biogeochemical data, except from some of these Argo floats which are carrying biogeochemical sensors. And as I mentioned earlier, one mooring in Arabian Sea has a pH and CO2 sensor, but its length is just over a year. And another one on one of those Rama moorings in the Bay of Bengal, whose length also is not more than 3 years. So that is all the data available. And now INCOIS is also planning to put another 6 moorings with different kind of biogeochemical sensors, and to monitor the waters around India on a continuous basis and develop models for that purpose. And the bottom panel shows the Argo floats, which has the oxygen and the biogeochemical sensors. So this data availability is still limited, but we have made beginning in those directions. So this data will build up. Right now, the ocean observing systems maintained by India, if you take a snapshot, it will look like this, with Argo floats, ADCP moorings, wave rider buoys, and moored buoys, etc., etc. So the earlier in 1980s and all, we never had any of these kind of observing systems. Now the observing systems are reasonable, but not enough yet, but we are making progress in this direction. I hope this data will be useful for the research students at the universities to make sense out of this data. So the conclusions are, though we have a number of observing systems, the data available from them are still insufficient to detect signals due to climate change. At the best, they are right now useful for studies on intra-seasonal and interannual variability. Last decade saw systematic increase in quantity and quality of observing in the oceans around India. That needs to be sustained in the coming decades as well. Sustainability of the observing system, it is complex, has lot of aging parts, needs lot of love and care. Maintenance and refurbishment become more important as time goes on. Major international collaborations, because we will ourselves alone will not be able to invest so much to make these observations. So the programs like Argo, International Argo program, Drifter program, similarly the Rama mooring program. So these kind of programs we should join hands with other countries, and we should have the international collaborations to achieve nurture the observing systems and make sure that the continuous data is available for a longer and longer periods or a few decades from the Indian Ocean region, so that we can answer many more questions in this region. So the way forward is establish the baselines and predictability of Indian Ocean climate and the attribution of climate change. Some modeling efforts are required. Model the current and the future climate of the Indian Ocean and its impact on Indian monsoon fisheries and biogeochemistry. We still don't have a good idea on any of this. So there is a lot of opportunity in the modeling and the data from the Indian Ocean, and very high resolution climate change projections for Indian Ocean region. Water projections, which I showed earlier, they are all global projections. So that may not be exactly same for Indian Ocean region or our region. So we had to set up very high resolution models and take leadership in developing them. So develop a science leadership and support. And I hope that is what the universities, especially Andhra University, is doing, and developing the leadership for the future of our country. So thank you very much.
Yeah. Thank you, Dr. Shenoy. Now the session is open for questions. Dr. Shenoy, there is a question from an MTech student. He would like to know why the Indian Ocean is warmest among the world global oceans, and it is alarming in last few decades. Is it due to increasing CO2 emissions or anything else?
Yeah, that is what the question I am raising. The Indian Ocean is warming at a much faster rate in the last couple of decades, especially after 2003 onwards. And one evidence which I believe it is more concrete is that the warm waters from Pacific is getting pushed into the Indian Ocean through Indonesian through flow region. I still don't know what is the pathway for that exactly, whether it is through the Indonesian through flow region or south of Australia. That we had to figure out still. But the data shows that one of those slide which I showed clearly shows that in the lower levels of Pacific, the warming is becoming less and less, and Indian Ocean is getting warmer and warmer.
Yeah. Another question, Dr. Shenoy. Whenever we would like to update the sea surface temperature during the life cycle of a tropical cyclone, what is the best temporal resolution of SST data available right now?
Right now, in live, if you are talking about live, the temporal resolution data available is at 3 hours. Because though the SST is recorded every 15 minutes on those moved buoys of an IoT, all the data is not transmitted. That data will become available only when the hard disk of the buoy is retrieved, when the people go out and retrieve that hard disk. So though that data is available for the past, live data is transmitted only at every 3 hours.
Okay. And another question is from a student, is there any need of following a particular grid system for the observation platforms deployed in the open oceans, or are they taken care by the models?
These grid systems are fixed based on two criteria. One, because for example, when we are putting certain observing system, all observing systems are not observing every data. It is observing specific parameters. So what is the spatial correlation scales of that parameter? That is the most important. Second is how much you can afford. Sometimes you may need more, but you are unable to afford. So what's the best balancing we can do? So for example, the Argo floats, the agreement is that we should have one Argo float in every 3 degree grid, or every 300 kilometers approximately. But in reality, we are unable to maintain that kind of a balance. But that's what we are trying to achieve. Similarly, for drifters, it is 1 degree or 100 kilometers. Even that also is a little difficult to achieve.
Okay. Another question is, in the recent years, we are experiencing severe to very severe tropical cyclones, while the number of depressions are going down or reduced. Is it only due to the rapid Indian Ocean warming, or else can we attribute this to any other ocean phenomena? That is the question by a student.
Yeah, see, all this it's difficult to separate because along with the other oceans, Indian Ocean also is warming. Of course, if Indian Ocean was not warming, the tropical cyclones may not have been so strong like what we are seeing now. So definitely, Indian Ocean is the the warming of Indian Ocean plays the major role in that. And regarding the tropical, depressions, in fact, I will refer to that paper by Vishnu et al., where Professor Ramakrishna also is a co-author on that, and where we have shown that the upper air wind system is slowly changing, and those are the reasons for these lesser and less depressions which are happening. So it is majorly controlled by Indian Ocean, but the changes happening elsewhere also are important.
And another question is, a student is interested in using the Hurricane WRF model. For that, is there any bathymetry data available for the research community from agencies like INCOIS for the Indian Ocean, North Indian Ocean?
INCOIS has not generated a bathymetry of its own, though we are trying for last couple of years. Of course, now MOES has initiated a process which NCS is leading, and especially the bathymetry, the problem is nearshore bathymetry, which is changing. But for the time being, even in INCOIS also, we are using this either that eTopo, high resolution eTopo data, or JEPCO data.
JEPCO. Okay.
Yeah.
Yeah, and I think probably the last question, it is a layman's question. During the pandemic COVID, there have been many lockdowns and all, and then we had reduced emissions and all. Is it going to put any effect on the oceans, the reduced emission levels and all?
I think some of those might help the oceans to become better, but the issue is the carbon dioxide, for example, already put out in the ocean or in the atmosphere also. These will take hundreds of years to get removed. So by just reducing 1 year, we are not going to achieve much. That reduction should be consistent and go on reducing for decades and decades. Otherwise, this is a very small blip which may not help much.
Well, thank you, Dr. Shenoy, for accepting our request and also giving an elucidating talk on the role of the oceans and in the climate. And with this, I now invite our head of the department, Dr. C.V. Naidu, to propose a vote of thanks to the speaker.
Thank you very much.
Good evening to all. I thank all the persons who have attended the lecture entitled Need for an Ocean Observing System to Monitor the Changing Climate and Its Consequences, delivered by an eminent scientist, Dr. Satish Chandra Shenoy. Dr. Shenoy is an internationally reputed scientist and served in the highest positions in various prestigious institutions like NIO, NQuest, etc. Dr. Shenoy contributed good science in the field of circulation and air-sea interaction in the Indian Ocean. Dr. Shenoy has been publishing high-quality research papers in highly reputed journals by adding good essence of ocean science. Sir, your services for the development of ocean science are laudable. Sir, you are in our hearts with the highest reputation. Your talks certainly enlightened many students and scientists. I should be thankful to you, sir, for delivering very informative lecture to student and research communities. Thank you, sir. Thank you once again, sir. Namaste.
Thank you, Dr. Shenoy.
Thank you very much. Thank
Namaskar.
you. Thank you. Namaskar.
నేను అడుగుతున్నాను ఏమన్నా క్వశ్చన్లు ఉన్నాయా ఎక్కడి నుంచి వచ్చినాయి